Hello, maurieo. Ask me anything. Total station radiation question. Hello, and welcome. Well, I've had a little question from one of my subscribers and viewers about a total station radiation question. So they've sent in an email and a little diagram. So let's have a look at that and let's see if we can come up with a solution. So, hi maurieo, I have a small question about the secure total station theodolite. Say point A and B coordinates are given there and see the attached image, and if we are to find the coordinates of C, which is effectively just a radiation from A, we first set up at a known point A and calculate delta E and delta E from the calculator to point B, so we can get the distance and bearing of AB. Then we set the theodolite face left to B and turn clockwise to C to get the HAR angle, diagram 1, from face right to C. The thing I understand to do you turn face right from point C to B, the black angle, or the red angle in diagram 2? Okay, well, looking at this question here, you can see there's a number of little things or concepts here that need to be perhaps a little bit better understood. First of all, it's that we measure, when we're measuring with an instrument and using in this manner, we're actually, although we're measuring the, we can say we're measuring the angles, and in this case, attempting to measure the angle directly, we actually measure the directions is probably a better way of looking at it, and to measure the directions. Also, it's as long as the instrument is measuring clockwise, in other words, that the bearings are increasing clockwise, it doesn't matter which way you turn the theodolite, because it's just measuring the direction from A to wherever you're going. So it doesn't matter which way you turn, it's sort of trying to relate to what it is you're actually measuring. So certainly if you set 0 from A to B and turn clockwise, you would be measuring the angle BAC, this angle, the red angle, and that's the way it is. However, that's not the way that I would do it, in the way that I've been trained here in New Zealand. So what I would do is, first of all, here's A and B here, and we've got a bearing and distance between them, which we've calculated from coordinates or some way or other we know, and it's 64 degrees 57 49, and it's 100 meters. So what we would set up here at A, which is down here, set up at A, and we would attempt to set on the instrument or the theodolite this bearing here, 64 57 49, which is rather than the bearing rather than set 0, I would set the actual bearing, or try to set it. So this is what I've done here in this little field note where I'm at A. So face left, on face left I would set 64, I would try to set 64 57 49, and then I would take the actual reading. So I'd try to set it and then turn the instrument around through 660 and then take a reading to B. And that, what I've done here is said, well, the reading I got to B was 64 57 40. Okay, now that's on face left. Now there's a couple of things. I could then do a face left reading to C. So I could just turn the instrument round there to C and take a face left reading to C, which is in this case 311.5407. Take that to C. I could if I wanted to do a face right on B and then do the face left, face right on C. But typically I would do face left B, face left C, and then I would turn the instrument over and do a face right on C, which is 131.53.57, and then I would come back to B. It doesn't matter which way I turn it, whether it's clockwise or anti-clockwise, because I'm measuring the direction. Once I've set the direction, I'm measuring the direction. That enables me to determine the angles, but effectively it's sort of measuring the direction. Okay, and so then I'd come back to B and measure 244.57.30. And you can see that there's one I couldn't set 64.57.49 exactly, and there's a slight difference between the face left and face right in the seconds. Obviously the degrees will be 180 different. So then I take the mean of the minutes and the seconds. So 57.40, 57.30. The mean is would be 57.35. 57.35. That would be the mean. Now what I was trying to set the angle 64.57.49. So to do that, I've got to add an orientation correction of 14 seconds. So that would give me to this to 64.57.35 plus 14, 64.57.49. So that's my back sight. It's all set. I know that I couldn't quite set it exactly by 14 seconds. I then come to here and take a mean of these. So I've got 54.07 and 53.57. So 53.57, 3 seconds up to 54 plus 7 is 10 seconds. Okay, half of 10 seconds is 5, so I can either add 5 to 53.57, which would give me 54.02. That's 54.02 in there. So 54.02 in there like so, or I can take 5 off there, 54.02 again, and then I add my orientation correction to C, and that gives me 311.54 degrees 16. So now I have got my actual bearings in there. So I'm measuring my actual bearings. 54.57.49 is what I set there, and then I've gone through and adjusted, and I've got my actual bearing to C 311.54.16, and the distance is 74.629. I did this in AutoCAD Live using actual coordinates that I was familiar with. So, just to summarise, it doesn't matter which way you turn. You've just got to be aware as to what you're actually measuring. So, in my case here, I set the actual bearing and then measured the bearing around there. So then if I wanted to measure whatever angle I measured, I could do it by subtracting the bearings. So for instance, if I was to take 64.57.49 away from 311.54.16, that would give me this angle in here. Bearings are always measured clockwise from north. So, and then take that away. That would give me that angle there. Now, this angle in here, a little bit trickier to work out. You could, obviously 360's up in here, so you could subtract 360 minus 311, 54, 16, plus that would give me that angle in there. Or you can work out this angle down here, which would be 244, 57, 49, which would be that bearing out there, minus 131, 54, 16. So, the thing is that, yes, I think the best way to look at this is in terms of measuring the directions rather than the angles. There are methods where you can measure the angles. So if you wanted to measure that angle in there, yes, you would set 0 there, go face left, face right, face left, face left, face right, face left, okay, and mean them out exactly the same as you've done here with that at 0, and that would give you that angle round through there. But certainly the way that I've worked most of in my surveying is we have set up the actual bearing and measure the directions, and then everything's sort of live and how you want it, and you can calculate using the things directly. So I'm hoping that that's answered your question. If it hasn't, we've got the comments below, so certainly ask for clarification. Thank you for sending your question in. It answers a number of aspects and some very interesting concepts that really need to be understood. So if you have any further problems, send me an email or put something in the comments, and I'll respond as best I can. Cheers! See you!